So I'm Nick Harris. I'm a technical evangelist for Windows Azure. I work in Redmond. This is one of my co-workers on the right-hand side of me up there. They've been working in Redmond a bit longer than me, so they've lost their tan completely, and I just use him as a guide to see how much longer I should stay there. You can reach me on Twitter at CloudNick, and I've got a blog there as well. So this session, we're going to focus, as I said, on building device applications with Windows Azure. We'll look sort of in-depth at storage, identity, communications in the context of notifications, and also some of the platform services provided by Windows Azure and tools. We'll have several demos. We'll demo WinPhone 7 storage, utilizing cloud storage. We'll demonstrate the access control service, so we'll make some demos where you can sort of go and log in using Windows Live, Google, or Yahoo across both WinPhone, iOS, and Android. And then we'll finish up with a WinPhone 7 demo of push notifications. So, I forgot this one. We're going to start with BabbleCam. So this is an application which you can download from the Windows Phone Marketplace already. It's up there, it's free. And essentially what it does is it translates a picture of some text into a foreign language. So I'd like to use this demo as a demonstration of what's possible using device plus cloud. And then after we demonstrate this, we'll dive into each of those separate verticals. So, just going to hit stop here. So BabbleCam comes with the Windows Phone toolkit for Windows Azure. And when you install it, actually installs into /Windows Azure by default, Windows Phone. And within that, we've got a whole bunch of sample applications, and BabbleCam is one of them. So whilst this is published in Marketplace, it's actually a free application which you can take, download, look at the source, and sort of do what you want with it. So I'll kick it up here in the emulator. Let me just back out of this. So what I'm emulating here is a bunch of services that the application is going to call into, and we've also got the actual client application here. I'll give the compute emulator a few seconds to start up here. Should have warmed it up. See how that's going. Okay, seems to be running. Right. So, BabbleCam. You seeing that up there? Okay, I've lost the I've lost the internet again over here, guys. this is going to make it quite a slow session. Let me try this again one more time. If we're doing this the whole time, it's going to be sort of difficult. Let's see how we go here. All right, that's better. So the first thing that we've done is we've gone out and we've called into Azure and we've pulled back a list of identity providers which we can use to authenticate the user. So I'm just going to use Google here for the moment. And it's I created a demo account. On the WinPhone emulator, if you hit page up, you're able to just start typing with your keyboard. It's a useful thing to know if you've sort of come from WinMobile development where you couldn't do that. I've got a relatively secure password here. So as you can tell, this is my personal Gmail account. So secure I can't even seem to remember it. 2, 3, 4, 5. Okay. So now we've signed in. So the first thing that we'd like to do with this is we'd like to enable push notifications, and essentially that's so we can receive a notification from the cloud with some information for us. So this has been implemented such that, if you've got your real phone and not the emulator, you can click on the camera icon there, take a picture of some text, and then get it translated. But what we've done in the sample application is we've just got this link here to translate some sample text, and this is just the text that comes with the default sample, and that's actually an image. So we're actually going to do a two-step translation. First one is to take that text, take that image, translate it to text. In this case, it's going to translate into English, and then we're going to take that and then translate that to a foreign language. So given that most people here probably speak French, I'm going to say, okay, let's take this image and convert that into French-based text. So we've uploaded the photo. Now we just wait. So we've uploaded that photo into Windows Azure. Now we're waiting for it to go out and perform the translation for us. So there it is there. So we've got that, and it's come back down. And we've got some French here, which I'm not very good at reading. But hopefully it makes sense to you guys. So that's a very high level of sort of what's possible. So I'm just going to back out of this, and we'll jump back into the deck. So let's have a quick look at what really happened there. I walked through it a bit, and I'm going to have to rush through a few slides just to make sure we finish up on time. But we'll try and slow back down when we hit demos. So the first thing we did is we authenticated the user. So we utilized the ACS, which is the Access Control Service of Windows Azure, to do that. That returned back an access token. Now that access token we can use when we're making requests out to our services in the cloud. And in this case, what we did first is we requested a shared access signature. And what a shared access signature is it's a time box token that allows you to go and write directly to Windows Azure storage without having to keep the storage account credentials on the device. So when we got that shared access signature, we took the picture and we uploaded it into storage. Now from there, we had a worker role that was hitting storage to say, hey, are there any pictures that need translating here? And it's pulled back that picture to be translated. It's looked in Windows Azure table storage, and then it's figured out that we want to go from English to French. So what we did then is we took that, and then we pushed it out to the Hawaii OCR service. Now this is a Microsoft research project, and it just takes an image and then converts that image into text. So it took the English image and returned back some English text. And then from there, we pushed it down again to the Bing translator, specifying that we want that back in French. Then once we'd completed that, translated text come back, and then we decided to push a notification to the device. So you've seen how, without me pressing anything or refreshing anything on the device, that French text surfaced up in the application. Now, that isn't because we're polling or anything like that. We're utilizing what's called push notifications in WinPhone 7. And to do that, you essentially push a notification through what's called the Microsoft Push Notification Service, which eventually delivered the translated text to the device. So that's Babelcam at a high level, and also shows you how Windows Azure components can start working together to provide a useful solution. But the real features we've seen in action there were storage, identity, communications, and platform services. So what we'll do now is we'll sort of drill down into each one of these individually. But firstly, maybe you may be thinking, why build a device application that's leveraging, say, the cloud? So the first thing is it allows new application scenarios. So consider if you have a device application and you're just building an app that runs solely on the device, it's not really going to be able to do much. You may sort of take it to the next step and start calling out to services to pull down data and create sort of mashups. But if you go out and start building your own services, you can start making unique applications. And in this case, we build a translation app. The second point is the cloud actually levels the playing field. And what I mean by that is if you're perhaps, say, a small startup or something like that, you may not have, I guess, the funding or capital to go out and purchase hardware. Hardware can be quite expensive. So what this means is while you're still prototyping or perhaps just putting your startup business out there just to see if it works, you can start small. You can start with a small instance and not really be getting charged a significant amount of money. You don't need that upfront investment. If it goes well, you can scale up quite easily, but if it doesn't go so well, you can sort of scale right down or back out. So the last point here is what the cloud's providing you really is a way you can reach across device platforms. So say, for instance, you build out your services and architect them correctly, then you'll be able to consume those services, that same set of services, from multiple device platforms. So in this case, we're going to show you how to do that WinPhone 7, iOS, and Android. So why Windows Azure? Well, as you've seen in Scott Guthrie's keynote today, he went out and looked at Windows Azure, and you've seen that just creating that first application, which was an MVC app, it's quite simple to say, file new project, you get your MVC application. Really, when you're developing for Windows Azure, you can I guess you can focus just on building your application. You don't really need to worry about going and setting up an OS or installing, say, SQL Server and these sorts of things. It's all there for you. You just develop locally, then publish, and then all that management, automatic OS patching, all of that's taken care of for you. Elasticity and scale is more around how you can scale out. So you'll recall that he went from 2 instances to 99 instances where he had the little alien face. On top of that, utility billing, pay only for what you use, and we've also got a higher level set of services there, which covers like ACS, caching, CDN, and traffic manager, which we'll drill into later. But let's dive a little bit deeper on storage, and we'll look here at some of the common patterns that we find people using over and over again when they're developing mobile applications that utilize Windows Azure. These are, I guess, more so best practices. So let's look at what these storage offerings are to start with. So Scott touched on them briefly. We'll just do a quick recap here. So we've got Windows Azure Tables, and that's non-relational structured storage. So it's a bit like NoSQL. It supports massive scale out. So that one particular table, for instance, you could grow that up to, say, for instance, 100 terabyte, just based on the default storage account size limitations there. We've got Windows Azure Blobs, and this is a great place for you to go and store binary data. So you can go and put, say, your images in there if you're building picture-based applications. If you're building a media-based application with video and such, you can upload that content to blob storage. If you're dealing with document type apps, you can put that content there as well. We've also got Windows Azure Queues. So they provide persistent async messaging. And it pretty much allows you to in-queue work and de-queue work, but it's a really good way to offload perhaps a long-running task from a web role to a worker role such that you've got that responsiveness back to a client application. And lastly, we've got SQL Azure. So anyone who's done relational database development, it's a relational database. If you've developed for SQL Server, SQL Azure, your skill set's going to transfer directly across to that. There's only a few minor differences that you're going to need to consider there. It's highly available, and again, it's managed for you. So we deal with the backups and maintenance and tuning. So when we're using these, being SQL Azure and storage, there's some secrets that we need to keep. And these secrets are, as far as the storage is concerned, it's the storage account name and the storage account key. So in the portal, that's what your storage account looks like, and that would be a key that you really don't want people to get at. So this is something that you wouldn't put in your device application in a configuration file. It does happen. I've seen it there before, and what can happen is if that's compromised, then someone's got access to your storage account, and they're going to be able to utilize that 100 terabyte of data to do whatever they want. So you need to prevent them from doing that. And we'll look into how you can do that in a second. For SQL Azure, it's just the connection strings which you need to protect. So that's just an example of connection string. What's most important really is obviously the username and password. So key point, once you share your secret, it's no longer a secret. And then, if people want to use that in a bad way, then they probably will. So to keep them a secret, we proxy requests. Excuse me. So we're going to repeat this proxy pattern several times here. It will seem a little bit repetitive, but it's really important to understand that you need to proxy your requests so that you don't store that key on the device. So let's look at how we do that with table storage. So the first thing that happens is the device sends data to a web role. The device does not have that storage account name and key. The storage account name and key is actually stored in configuration in your web role. That data is then sent from there to table storage, and it's as simple as that. Likewise, for blob storage, you can, if you wish, you can go and say, okay, I want to go and upload that image, for instance, the image from Babbelcam to blob storage. You could do that by saying, okay, let's send that image directly to the web role, then have the web role serialize that to the blob store account. Now, that's going to work from the perspective of you're not going to be sharing that secret, but it's not really the best way to deal with blob storage, for instance. When we work with blob storage, there's another pattern which you can use. And it's the pattern which we briefly discussed about using shared access signatures. So what you can actually do here is you can say, call into your web role, and you stand up a little service. It's not many lines of code, really. And what that does is it returns back a shared access signature. So that was the timebox token, which says, for instance, anyone utilizing this token can go and write directly to a storage account for that period of time. So what we do is we return back that signature to the device, but then we allow it to go and write directly to blob storage or read from it if it's a private container. Now, the key point to note here that's also different about this particular pattern is if you have a web role, let's say it's a small web role, by default, if you're considering just the network trunk into and out of them as far as bandwidth's concerned, every machine that you consider, that you're calling into as a service, there's going to be a set cap on the network that you can use. For a small web role, that's 100 megabits. For an extra large web role, that's 800 megabits. And by doing this, rather than serializing that whole blob, which may be a meg, through the web role, which we were doing in the prior pattern, we're now only requesting a very small token, and we're offloading that serialization to blob storage. So what this means is, as far as I guess your spend is concerned, it means you can, by using this pattern, if you're dealing with blobs, you're going to be able to use a lot less web roles, so you're not going to be spending as much money. So when you deal with blobs, particularly if they're private and your devices are uploading them, use a shared access signature. So SQL Azure, likewise, similar to table storage, just request, proxy the request, or return the data, or likewise. The last pattern that we see is offloading work through queues. Now I haven't put the proxy in here just to, I guess, minimize the amount of moving parts on the slide, but essentially you'd have a proxy for the queues as well. They require a storage account name and key to access. But the pattern we see here with offloading work to queues is it means you can offload a large task that's not really going to run very fast on a phone, say the translation service, which we just looked at then. We can offload that task and have the compute or power of the cloud go out and perform that task for us much faster. So in this case, we upload a job into a queue. The worker role then pulls that off the queue, and then it goes off and deals with that particular message. So let's jump into a demo. And the first demo here, we're just going to do a Windows Phone-based demo, and we'll perhaps what we'll do is we'll create a Windows Phone application, we'll take a picture, we'll upload that to blob storage, and then we'll add a row in table storage table. Now, all these bits which I'm about to use are publicly available, and what they are, they're actually from the Windows Azure Toolkits for devices. In this case, it's going to be the WinPhone one. And they're accelerators to help you build out applications fast without having to invest as much time as you would to go out and build those particular proxy services. So let's close down Babblecam. Let's go File, New Project. So who here has used NuGet before? Right, so NuGet essentially allows you to bring down a library that someone else has created into your project, and part of that, it can be assemblies, or it could just be source files or configuration type details. So we're going to utilize NuGet here to pull in functionality to go and deal with our table service proxy we're going to build. So the first thing we need to do is we need to put a couple buttons on there, and we need a text box. So we're going to use a text box just to specify the picture name. And the button is going to be to take a picture. And just because we lost some time at the start, I'm just not going to bother changing the name on there. Now, some code. So we've got a camera capture task in WinPhone 7. What that allows you to do is to interact with the camera and say, take a picture. Don't worry, I'm not going to code the whole time. It's just where I don't have my snippet created for it. So there's our camera capture task, and when we click the button, we want to show that camera capture dialog. Now, we need to do some wiring up. So what do we do once we go out and we capture that image? So what we're going to do here is we're going to new up the camera capture task in our constructor, and we're just going to wire up a completed event handler there to say, okay, when we take a picture and the result comes back and it's okay, then we're going to do something with that. And what we want to do is we want to go and upload that to blob storage. So let's put that in. So what I'm using here is the blob client. Now you'll note immediately that, okay, this is not a library that's recognized. We're going to need to go and add in that functionality somewhere. So this is where these little accelerators, the NuGet packages that we created, come into play. So can you guys all see the bottom right from the back up there? Is that okay, up the back? Thanks. Okay, so we're going to install a package here. And we're going to install phone.storage. So this is essentially a storage client library for Windows Azure. So has anyone actually used the Windows Azure storage client library from, say, a full MVC application? Have we got any Windows Azure developers in the room? We've got a couple. So some of you may have. Essentially, this provides the same functionality, but it's a library for the phone. So we've gone and pulled that in, and there it is right there. But what we also pulled in with that is there's some documentation here, and all of these NuGets, which I'm going to show you today, have detailed documentation on how you can go and utilize these NuGet packages and what they pull down for you. So we've got that in. Now, if we jump back over here, we can actually go and resolve this. I'm just using, let me save all that. Just going to use control dot. It's a shortcut for adding your using statements. And what we do here is we say, okay, let's get a reference to a blob client. And we want to get a reference to a container that we're going to create. So in Windows Azure Table Storage, a container is similar to a folder. We use the term container because it's not actually a folder. It just looks like one. So we get the container reference, and we pull the image name from the text box. Now, first things first, if the pics container doesn't exist in our storage account, we want to create it. And once that's created, we then need to create a blob and then stream the blob from the image on the phone into that container. Once that's done, we need to add a callback. So recall how I said we're going to upload an image to blob storage, and then we're going to add a row in a table for that. Well, we're actually going to add a row in a table for that which has just the name and the URL to where that blob is stored if we want to look it up and use it in our application somewhere else. And to do that, we'll use the table client. So again, a similar thing here. We've got, we get a reference to the table client. We create the table. We're going to call it the same as the container. We're going to call it pics. Create it if it doesn't exist. And then once that create operation is completed, we're going to go and create a row for that. And we're just going to create a simple entity here called sample data. So that sample data then is added to the context, and then we go and save the changes into that table storage. Now, to do that, we need to use something that's a little bit special. It's not exactly your standard sort of DTO type entity, because we need to inherit from a base class. And this provides some key properties or properties which define the uniqueness of that particular row in the table. And it's something that needs to be used with Windows Azure Table Storage. So, just got another snippet here. So what we do, so I'm just going to resolve these guys with control dot again. And again, these are using that storage client library, which we pulled in earlier. So the key thing to note is this guy, table service entity. And that defines the three key properties that every row in a table in Windows Azure Table Storage require. It's a petition key, a row key, and a timestamp. So if you've done any relational database development, note this isn't relational, but the combination of a petition key and row key is similar to a composite primary key in the table for SQL. So to uniquely identify a row within this particular table, you need both of these guys. So that's our entity, and we've got some properties here, just name and URL. So that's it as far as the code's concerned for creating the blob or capturing the blob using the camera, uploading that blob to a storage account, and creating a table. Now, let me just recall. Next step. So we've got that, but we talked a lot about, okay, well, if we're going to go and write directly to a storage account, we don't want to have our keys on the device. So whilst this library does allow you to go and write directly to a storage account, we actually want to go and create a proxy service to go and proxy these requests, and we'll do that right now as well. Create a new MVC project as a Windows Azure Cloud project. When you install the toolkit, you do get this additional template here, which I'll just point out. If you're not sort of too confident in jumping in with NuGet to start with, this phone project will essentially generate a sample that shows you how to utilize all the pieces. So it's sort of a good place to start if you don't want to jump in dirty straight away. So we'll add our MVC role there. And this is where we're going to proxy our requests through. So it's just going off and generating the standard MVC cloud project. Just going to minimize the cloud project there. Now what we need to do is we need to go and put in these proxies, and we've developed a NuGet for that as well. It's equal sign, sorry. And what we call this one is Windows Azure storage.proxy, if memory serves me. Yep. So this provides a whole bunch of proxy services for tables, queues, blobs. As far as blobs concerned, the default will utilize a shared access signature. And it goes and drops them into that MVC project. So quite literally, I don't have to do much to get that working. If I just come in here and point out a couple key pieces that pulled in, the first one would be the Windows Azure Storage Proxy. You can see that's a library that we pulled in there. And we also externalize the configuration of that library. So really, you don't need to jump in and get your hands dirty in how does all of this code work, unless you really want to. You can instead just come here and specify, the configuration for it. For instance, how long do you want a shared access signature to last before it expires, and things like that. So if you do want to dig into the code, what we've got here is all the code for these NuGets that you're seeing, plus a lot more, are all up on NuGet. So you can go pull them down, dig through them, adjust them to your needs. As Scott mentioned this morning, if you find a bug, feel free to fix it and then commit that back so we can sort of rope it back in. So that's our storage service. Now the next thing we need to do is we actually need to spin it up, and we need this phone app to then call in to this proxy and then go off and push that data up. So let's come in, and we need to do one small adjustment on the default storage initializer for the phone app. So like the MVC project, we externalize that small amount of configuration for you as well. So by default, we say, okay, let's go straight to the dev storage account directly, but we really want to go out and we want to utilize the proxy pattern because we know that's a safer way to deal with our keys. And by default, we've just got it set up here to use our local host account. So I'm going to start debugging here. Fingers crossed. It's actually it's 7:50 a.m. back in Redmond, so I've sort of pretty much pulled an all-nighter. So if I make mistakes here, don't hate me for it. I know it's a cruel world, but it's not that cruel. So here we go. There's our client application. Now let's start by specifying. Let's just say pick 10. So we're going to hit that button, and there's our camera capture dialog for the phone-based application. We're going to hit accept. This is sort of as nice as the pictures get by default in the emulator. And when we hit accept there, it went off, and then it called into our proxy service using the configuration we just showed here, uploaded the image to the local storage account via the proxy, and then added a row to a table. So what we can use is some free tools here which you can download. This is Cloud Explorer, and allows us to go out and explore our local dev storage account. And if we look here, we can see that pick 10's gone up there, and there's our picture. If we want to do another one of them, let's put pick 11 in, hit the button there, save that, hit accept. And then we'll give it a second over here, and then we need to refresh it. And there's 11 there. Now, so that's a picture, but we've also got a record in our table storage account here as well. So here's pick 11, and that's the URL there. Now you can see that that's been uploaded into the local storage emulator, which is available down here in the toolbar. So there's the storage emulator. Just as a quick tip or trick, if you want to reset the contents of that, be it wipe it all, you just hit reset. So we've essentially built an application that takes a picture, uses best practice proxy pattern to go and push a blob up using a shared access signature to a storage account, but to also proxy a request to store some data in a table. So for any of you developers out there who've tried to do that before, you probably are aware that this requires a significant amount of work. And these NuGets are here to help you not have to do that again and just focus on building out your app logic. So that's the WinPhone demo. So did you guys want to see it sort of push that data up into a real cloud storage account, or shall we just move on? Anyone want to see a real account? Can't see up there? No. Okay, we'll move on because we did lose sort of 10 minutes at the start. So let's look at identity. So we've dealt with storage and we've gone and pushed that in, but most applications need the capability for the user to sign into them, because perhaps you want to associate something with that unique user back in your back-end services, or you might just want to make sure the user's authenticated, so you know if you know who, or you can go and blacklist a particular user that is perhaps trying to use your service APIs the way they're not meant to be. So they may be sort of pushing in fiddler requests or something like that. Now, when we talk about identity, there's several options. So you can create your own, and way back when we first sort of started out with this stuff, people may have been going out and implementing their own sort of username, password scheme, or token scheme, etc. From there, we sort of worked out and moved forward into ASP.NET membership providers. But I'm sure a lot of you out there perhaps have used websites that may be using that, and you've sort of ended up with so many usernames and passwords that when you eventually go back to the site, you forget what your username and password was for it. So what came in then was the ability to utilize these single existing identity providers, so things like LiveID, Facebook, or Google. But to do this, you need to develop directly against the protocol specified by that identity provider. And as you may know, if you're a Facebook developer, for instance, sometimes those protocols do change to a degree whereby it's going to cause your application to break, and you're going to need to implement some changes such that your authentication is still going to work. So the other option is, rather than going off and perhaps having to deal with that breaking code or go and implement multiple identity providers on your own, you can outsource your identity management to ACS. And what this essentially does, the access control service sits as an abstraction on top of each of these identity providers and allows you to interact with just one particular provider, being the access control service, and it will broker all that's required as far as going out and authenticating against that user, and then taking what's returned from those and composing them into, say, a token that can come back, and you only need to deal with that one protocol of ACS there. The other benefit of it is, obviously, being Microsoft, we go out and we deal with these major identity providers, so we know well before the changes are occurring that they're occurring, and then we go off and we have the fixes in place for when those protocols may change, such that you're not going to get any downtime with your particular application. So let's have a look at using ACS from Windows Phone, Android, and iOS. So jump into the demo here. How are we doing on time? 35 minutes. Okay. So I'm going to jump over here. So this is the Windows Azure portal at windowsazure.com. And we've got the access control service here under the Service Bus Access Control and Caching option in the menu there. Now, to create a namespace here for ACS, it's as simple as coming in, finding a free one, selecting a particular region that you want it deployed in, and then hitting create namespace. Now, that typically takes 30 to 60 seconds, but for the demo purposes today, I've gone and created or provisioned an empty one here called EU TechDays. But what we're going to do is I'm going to show you how quickly you can go out and configure ACS to authenticate against Google, Yahoo, and Live using ACS. So the first thing we need to do is select those identity providers that you're going to go out and utilize for your user to authenticate. So you can go out and authenticate against ADFS if you want. You can also utilize Facebook, but these two typically require a bit more configuration information. Say Facebook needs your developer ID and such. So today we're just going to do Google and Yahoo because they're quite straightforward. So I've just added Google as an identity provider. Now I'm going to go and add Yahoo. Save that in. So now we've got those three identity providers. The next step we need to do is we need to go and create a relying party application. So a relying party is essentially the application that's going to use this configuration to allow users to authenticate using these identity providers. If you're building an MVC website and you want to use this, well then it would just be your MVC website. And in this case, it's going to be our Windows Phone application or an Android or iOS application. So we'll say, we'll call it EU demo, and that's just an identifier so you can find it later on. We're going to specify a realm. Because this isn't a website, we're just going to use URI, and we'll say EU demo again. We don't need a return URL or these other information. We're going to use the token format, which is the token returned from ACS after you've authenticated against one of those identity providers. Essentially, it's a common format that you're going to get back, and it's going to be the same whether you go out and authenticate against Live, Yahoo, or Facebook. So as far as your application's concerned, you only have to deal with this one protocol to support all of these different IDPs. So this is a simple web token, and it's quite useful when you're doing sort of REST-based services and such. And we're going to generate a signing key there, and that's pretty much it for setting up our relying party application. Now, the last thing we need to do is we need to specify how we go and map claims from the identity provider back into that simple web token. So what we can do here, this is a default one which it goes out and creates when you create your ACS namespace. If I can step into here. There we go. And what I can do by default is I can go out and I can generate all those mappings for those claims for each of those providers. So I'm just going to do that here for those. And you can see what we're doing is we're saying, well, Google's returning by default, we're going to request an email address, a name, and a name identifier. And when that goes and gets mapped back to the simple web token that's returned to our consuming application, these are essentially the names for those particular claims that we want them sort of serialized as. So it's gone out and done that for Google, Yahoo, and Live. So that's it as far as that's concerned. Now, one thing I do need to remember is two things here, because we're going to need these in our phone application. So we need to remember the service namespace. We also need to remember the realm. So I'm just going to copy the realm and namespace EU TechDays. Okay, so let's create our phone app. Stop this one. And we're going to create just a simple Windows Phone application, no cloud project required. So one thing to note here is, as Scott sort of mentioned, you can build applications that don't require all the separate services from Windows Azure. In this case, we're just going to go and use ACS. We don't need compute. We don't need storage. We're just going to use ACS to field out that authentication process. Now, what we're going to do is install another NuGet, which we've gone and developed. And this one would be phone.identity. I'm just going to hit tab here so I can pull back the list. So here we've actually got several different NuGets. So if you were using membership, the option's there, but we're actually using ACS. So we're going to pull in the access control base page. And I'll show you what that looks like in a sec. So again, details of how to go and configure all of these items. But let's have a look at the page that it put in. So it's gone and put a login page here, and you can't really see much information there at the moment because it's bound at runtime. But if we come down, the important thing that's dropped in is this handy user control, and that was pulled in as part of our NuGet. And essentially, this user control will be configured to go out and hit a service, which we just configured in the Windows Azure portal for ACS, and pull back that list of identity providers that we want the users to authenticate with. And to do that, we need to do a few steps in our application. The first one is we want our app to actually start out by utilizing this login page. We don't want it to go to main page. So we're going to say pages, login page. So that's going to be our default page that we hit. Now, after we hit that page, it's going to authenticate. And once that authentication is completed, we want to navigate somewhere. And in this case, I want it to navigate to the main page. And likewise, if the users, the cool thing about this user control is once the user authenticates and that token comes back, it goes and stores it for you. So you can, every subsequent request to your web services, for instance, you can utilize that particular token. And this bit of logic here essentially says, if you're navigating to the page and you've already got a token that's valid, well then we don't need to navigate again, and we're just going to dump the user back into the main page. Now, while I remember what we need to do to allow that user control on the login page to go and talk to ACS, we've externalized the config for that as well. And we need the ACS namespace, EU TechDays, which is the namespace we provisioned in the portal. So you can see that it's still here. And then we need the realm. Should still be in my clipboard. And that's it. So now we should be able to have a user get those identity providers, choose which one they want to use to log in, and then once they've logged in, they'll hit the main page. Now, to show you those claims which we talked about, what we'll do is we'll put in a text box here. So I think for Google, we had a name identifier, an email address, and the actual user name. So I'm going to put this text block on, and what we're going to do is we're going to go and pull out those claims and display them to the user. Not that they're sort of useful for users, but it's sort of something you would then use to push back into your service. So let's fire into the loaded event here. Hit F7 to go to the code behind, and then ACS token. So here we go. Now, these again are classes that are pulled in with that NuGet package which we pulled in earlier. What I'd like to show you here, there's those several claims that we talked about, but there's actually a significant amount of claims which you can go and request and configure in ACS. These are all things which may be useful to your application. But again, when you use these things, it always directs you to a page and says, do you trust such and such with this information? For instance, if I had day of birth, you're going to get that in your application. And you'll probably see that here. So let's spin this guy up. So now it's going, it's hit that service, it's pulled back the identity providers which we configured in the portal. Now we can go off and authenticate against one of these. So I'll use Google, and we'll use that same one. And then apparently I had to do that so it wasn't a weak password when I was signing up. I think it's 5 there. There we go. So now this is where it says, do we trust the EU TechDays and access control? I assume the first one is yes, so we're going to hit that. And, and then here we go. So it's come back, and it's got those claims which we'd configured to be requested in the portal. We've displayed them on the screen. So that's pretty cool, but the cool thing about this is it's not something that we have to just use from Windows Phone. We can also do this from any other device, be it Windows 8. The Windows Azure Toolkit for Windows 8 has a similar control in there that you can use, but also with iOS and Android. We can do this as well. So what I've pulled up here is it's just Eclipse. We've got an application, and this application uses the Windows Azure Toolkit for Android. And as you can see down here on the left, we've got a whole bunch of classes here. That's essentially similar to the first NuGet which I showed you for Windows Phone, which was the phone.storage NuGet. In Eclipse, I'm not sure if they have something similar to NuGet, but what we do is we just distribute it here as a library, and then you can go and program against it. Now, over here, what I've done, and just for the sake of time, I won't update them, but again, the configuration that you've got for utilizing this storage library and the associated controls that we build out on it as well, is you've got the same configuration, and that's to go and say, specify your ACS namespace and the realm. These are a different namespace and realm, but the key point I'd like to make is, essentially you can use the same one we just configured there. For the sake of time, I'm just going to run this. We've got 23 minutes left and quite a bit to get through. So I'm going to run this test application. This test application comes with the actual toolkit. So I've got a little Android emulator here. Hopefully the app will pop up. Our Android and iOS skills aren't as great as our Windows Phone skills. So the UI could probably do a bit better on the sample app side of things, but the storage client library is in parity with what you've got for Windows Phone, so it's got just as much power. So there we go. Again, we've gone and hit that. It's pulled back the list of identity providers, and now I can go off and log in using Android. That's what you can see there is it's remembered my credential in this particular case, and it's gone and pulled back that token. Now, this is what that raw simple web token looks like. In the Windows Phone example, we used that nice managed API to go and pull out the claims, but you can see there's a claim, Nick Harris. There should be an email here. There's the email address, and name identifier will be in there somewhere as well. But let me try and power this guy up here. Let's cut across to the Mac here. Just make sure we got the right screen. It's working, okay. Let's log in. So on the Mac, we've got a similar story. We've got the library, storage client library. Again, allows you to accelerate the development of those scenarios that we've seen for phone. So we're really trying to make this open as far as it's concerned for all these different devices can go and leverage Windows Azure the same as you could with a phone. And the services that we're using to do this are all the same and reusable. But here again, in our sample application for iOS, we've got the same thing. We've got the configuration externalized here into WAP Toolkit iOS samples. I'm double-clicking, so I'm used to double-clicking. There we go. And there's our namespace, and there's our realm. If I go and run this guy, we should get an emulator here. And again, there's our login method. I think the credential may be cached here still. And in this particular sample application, we have a few more things which you can do with it, like go and look at your table storage listing. And there, for instance, is our picks table that we had earlier. So that's that. So now let's jump back to the deck. So in a nutshell, that's ACS across Android, iOS, and Win Phone 7. Let me pull this up here, cut back. And you can do that all using the one ACS namespace. Cool. So let's talk about communications. So when we talk about communications from phone-based applications, there's typically two ways with which an application will send or receive data. And the first is device-initiated, and it typically requires a user to go and press something or some kind of background agent to go and poll something. The second we've got is cloud-initiated, and that's whereby something running up in the cloud can go and push information down to a device. So when we go and talk about device-initiated, there's a few things to think about. It may be just a simple HTTP request response. You may utilize frameworks like WCF or the OData client library. But the key thing I'd like to sort of point out here is really when you're developing scalable applications for in terms of services that mobile apps are consuming, you should really consider your wire format choice. So I'm going to show you a list of 8 people, essentially, against a few different wire format choices. And this has quite a big implication as far as scalability and cost is concerned. So this is those 8 patients coming back from a service, OData. So that's 8.5 KB. This one is a REST-based service. Again, you can see that the text is actually getting a bit more legible. So this is, I think I used a WCF REST service, returning back XML there. And this one here was actually a WCF REST service returning back JSON. And this one's gone down to 639 bytes. So you can see there, just even by looking at how clearly you can read it, that's a significant difference in the amount of I guess, bandwidth you're going to use when you're calling into your services. So between the first one and the last one, that's 13 times difference, right? So let's consider if you were using the first one, you'll need 13 more times as far as your compute's concerned to service that bandwidth. So recall how we said a small instance has 100 megabits bandwidth trunk? Well, we can get 13 times more value just by changing our serialization protocol down to JSON, and that's going to save you a lot of money. So definitely consider wire format choices when you're building out these services for devices. So that was device initiated plus the serialization format. But if we look at cloud initiated communications, we'll use WinPhone 7 as an example here. We've got several ways to go and push information to a device. And the first one is a toast notification, and that's that one which you see up there at the top. The second one is a tile notification, as you can see indicated there. The third is raw, and that essentially allows you to send raw data in a payload down to the device. Now, the reason why we go out and use push notifications in contrast to going and building your own is because it retains only a single connection between your application and the server for each of your applications. It's been implemented such that it's bandwidth and battery friendly. And the last thing, it doesn't sound too great, but it does need to be said. So the Microsoft push notification service for Windows Phone doesn't guarantee delivery, so you wouldn't use it for critical applications where, it's critical that this user gets the message. In practice, they're delivered and it's good, but there's no guarantee it'll be delivered, so don't use it for, messaging, say, an ambulance officer or something like that. So to do this, it's quite a simple pattern, and you'll see in the top right I've got star.ns there. And I use star because this is the same pattern used by not just the Microsoft push notification service for Windows Phone 7, but also for the other notification services used for, say, Windows 8, iOS, or Android. So what we need to do to enable push notifications is first request a channel from our notification service. And this is initiated by the device. The device will call into the notification service and say, I need a channel that I can address this device with. It returns that back, and then you push that channel up into your web role. Your web role will then store that channel such that it can use it at a point in time that it requires to send a notification to that user. So if we think of, for instance, say, a weather service would be sitting there in the web role, or you may implement it with a worker role, sitting there and polling a national weather service. At the point in time that it determined that the weather's changed, it would go and pull that channel and then send a notification to all the devices that are interested in the weather for that particular state. In the Babelcam example, again, we stored the channel up with the service, and once the translation was complete, we actually pulled the channel for that particular user and posted the data back to them. So when it determines its time, it's quite simple. You create a HTTP request. That HTTP request has several headers set depending on the notification service. The one for Apple requires a certificate to authenticate against the notification service. The MPNS authentication mechanisms for WinPhone 7. That one is you can do it without authenticating, but you will be throttled at a point in time. However, if you go and use a similar sort of certificate-based scheme, you can go off and implement it without, the throttle. Windows 8 uses OAuth 2. But anyhow, so we want to send this notification. So we go and package that notification in a HTTP request. It's got a payload, and we post that to the channel we've been given, and then that will send the notification to the device. So, happy days. We get, we get our weather update or we get our translation, and I can figure out how to get somewhere. But it's not always just a flat push to device. Sometimes you want the device or the device user to do something once it's got that request. So you can use a notification to actually tell the device to go out and do something. So in the case of BabbleCam, what we do is a raw notification for Windows Phone can only be, the HTTP request can only be 4 KB in total, 1 KB for the header, and 3 KB for the body. But sometimes the text you're translating will be larger than 3 KB, right? So the way we implemented it with BabbleCam was to say, well, hey, let's actually send that notification to the device, but we're just going to send a notification saying, there's new data for you. We're not going to send the data as a whole. So in this case, with BabbleCam, we sent a notification. It's a raw notification, and it says there's new data, and then the device will then react to that notification automatically and pull the translated text down from a service, and that's it. So it's quite a good pattern to understand there that you can go out and have the device react to notifications as well, and it helps you get around those scenarios whereby the base notification constraints may not be good enough to go and, say, implement something for your application scenario. So in BabbleCam's case, we needed a bigger payload size, but it wasn't supported. And this is how we've done it. So, as I sort of briefly mentioned, there's multiple different services here. We've got the Windows push notification service for Windows 8. Tomorrow I'll be giving you a deep dive on how that works. So I've actually been working with this for quite a while now, and I built out a toolkit which accelerates your development in terms of being able to utilize Azure to light up that new start screen that we've got in Windows 8 to see the tiles popping and peaking, but also to update the content, being the tile templates, the badges, and also toast notifications. So if you're interested in that, please do come along tomorrow. We've got the MPNS, which we talked about, and iOS has the APNS, and Android has C2DM. So there's quite a lot of them, but the point I'd like to make is make use of them. It definitely makes your app more engaging and allows you to leverage their platform. And in the case of the two Microsoft ones, they're free. I think the other two are free as well. I can't quite remember. I'm pretty sure they are. Right, so let's do a demo of sending notifications to Windows Phone. So I think we've got 10 minutes left, so we'll do this one pretty quick. So start with a blank Windows Phone application. And here we're going to pull down a package we created. I think it's base page, yep. So anyone who's published a WinPhone application to Marketplace knows that if you're using notifications, you need to ask the user to enable that. You can't enable it by default, so we need a page whereby they can do that. And what we've got here is a default page that allows them to tick that box. In fact, you're actually seeing that in BabbleCam. So what we need to do with this now is we need to say, hey, when the application launches, let's show this page. So we'll come here and we'll say, pages notifications page. So we've wired that up. And now we just need to build out that service that we talked about for Azure that's going to accept that channel, but also post a notification at the point in time that it deems necessary for that particular application to receive one. So we'll create a new Windows Azure project. And we'll use MVC3. Hit OK. That's creating, again, the default project template. We're going to come over and choose MVC3 web role for our target now. And in this particular case, we're going to add two things. One, the service that accepts the channels and stores them into table storage. And the second thing we're going to add is we're going to add a management UI that we can use to explore the notifications. So the first one is So this is what we call our endpoint registration service. It's a WCF web API service that the device can just call straight into. Again, the configuration on the device as to where it should point to call into this is externalized into app start again. So across all these NuGets, they're similar, and we're just using a resource that's specified in the application to do that. So this will be going to localhost again. So that's our registration endpoint in our MVC project, but let's go and add a management UI so we can send some notifications. And this is notifications management UI sample. Now, whilst this is good for going and saying, okay, I've played with notifications and I know which ones I need to use for my app, the actual UI portion of it is really only good for that. What you'd want to do is you'd want to build out a service that's going and parsing some data. So if it was a weather service, it's going to go and poll the national weather service, and then it's going to send that notification for you. The key point is to compose these messages within that last NuGet which we installed. It actually it uses what's called the MPNS recipe, and it's just a nice managed API. And in fact, while this spins up, I'll show you its usage. And it means forming that HTTP request and creating the XML payload turns into a nice object model with properties, and you can just new up like a toast, a tile, or a badge. So if we look at the controller that it pulled in, you can see we can easily create a new toast notification like that. It's pulling some data from the view model that's bound to the UI you're just about to see, and then we send it. So it really makes it quite simple to do this. And again, those who've done it themselves know that it's a bit of extra work to do that on your own. So what this has done is it's put in a new MVC area, and we're just looking at the controller for this. Sorry, that's the registration endpoint. We want to look at the UI here. And let me come back out of this app, and this last one's the one which we just wired up. So I'm going to hit Enable Push Notifications. It's Phone App 19. And what we've got here is that UI which you can use to go out and send these notifications. Now, when I hit Enable Push Notifications, it requested a channel from the MPNS. It pulled that channel back, and then it registered it up with our cloud service. In this case, it's all running local, apart from the MPNS component. And here's that channel. So we've got a channel here. Now we can actually send a notification to that. So the one which we used for BabbleCam is raw. And these can only be sent while the application's in the foreground. And here, in the sample, we just show you how you can intercept that and then push it up to the screen. But if we come back out and we go and pin this application, those of you with WinPhone apps may have seen some apps using this. And really, it's a space which you want to take advantage of. The tiles you see on the WinPhone UI here actually are a way to engage with your user and draw them back into the application. And it's something you get for free, so you should utilize these services and just program against them. And as you've seen, we've sort of got all the code that you require to do this. It's just a matter of pulling it into your application. So I've just set the front tile, but WinPhone also supports a back tile. And we can send information to the back of the tile as well. So I'm going to hit send on that guy. We can see that it's been accepted. And there's I typed the text in back to front. That doesn't matter. So this is that, and eventually that'll flip. But while we wait for that to flip, I'm just going to send you a toast so you can see the last one. So the other thing with toast notifications you should realize is you can specify target pages. So it's a good way to actually inject something back into your application from the cloud. If the user presses on it, they're going to be launched into a particular page like that. But we haven't wired up that page in this demo, so let's just send the toast. So there's the toast. Obviously, if you click on it, it'll push you back into the application. Let me see if we can cause this tile to rotate. Just sort of trying to get the UI to trigger it. It doesn't look like it's happening. But it does work, and it will work. But let's jump back to the deck, because we've got a couple slides in about 4 minutes. So, platform services. So this is the last thing. So we talked about the access control service, and we've seen that's a way of going out and essentially allowing a user to authenticate against multiple identity providers and removing the complexity of working with the protocols that each of those identity providers use. But we've also got some other sort of high-level services which your applications can take advantage of when you're developing for Windows Azure. The first one is the Windows Azure caching service. Now, this particular one, it's a distributed in-memory cache. So consider from the keynote this morning where you had, say, 2 web roles or the 90 web roles. All of those web roles can utilize the caching service to go out and pull data back. The cool thing is it's the one caching service, so the data you store in there is going to be accessible by each of those instances. So if you're building performant applications, caching comes into play, and it's very important. For instance, it's a good place to go and store, say, lookups being product lists or customer lists, for instance. You can pull them out from your data storage once, store them in the cache, and then utilize them from there. It means you're not going to hit disk every time you need to go and pull them again. It means they're coming direct from memory, so it's going to be lightning fast. We've also got a content delivery network, so your blobs, being your images or your media that you've uploaded, be it a video or whatnot. If you're building some kind of multimedia app, it's definitely worth considering this. So the CDN sits on top of a storage account and allows you to essentially have that content distributed out globally. At the moment, I think there's about 24 nodes. And what that means is, say, if I'm a user in Sydney, but my storage account was provisioned in, say, West Europe, what will happen is I request that particular video using the CDN within my application. That video will then be pushed out to these edge nodes around the world, and my app is going to actually download that from the Sydney CDN edge node rather than sort of coming all the way to Europe and trying to stream it back with the obvious latency that you're going to have there. Traffic Manager, it's essentially geo load balancing for your hosted services. So if you're building out these REST-based services that your applications are calling into, again, similar situation. If I'm in Australia or some other country and you're deployed to, say, West Europe, what you can do is you can actually deploy that same service in each of the regions, whether it's Europe, US, or Asia. And then Traffic Manager will sit on a layer on top of that, and you can configure it for performance-based routing. So when it hits, www.mysite.com/services, Traffic Manager will actually route that request to the deployment that's closest based on network latency to the specific user. So it's a good way to avoid sort of latency and the obvious thing that implies to users of your applications. The last one is SQL Azure Data Sync. So if you start distributing these things across different countries, well, then you need to start thinking about how do you synchronize your data between those. So SQL Azure Data Sync essentially allows you to synchronize databases, wherever they may be deployed. So that's it. Summary, we talked about devices and cloud. We drilled into storage, identity, communications, and platform services. We've seen quite a few demos and useful accelerators from the toolkits that you can go out and utilize in your own projects to get, I guess, a leg up and a jump start for WinPhone 7, iOS, and Android. Anyone who wants the links, these slides will be available online, and there's links there to each of the specific toolkits, which we sort of walked through a bit today. Getting started with Windows Azure, it's just windowsazure.com. There's free trial, which is 3 months. These are some of the things you get with that, but it's definitely worthwhile as far as if you want to go out and play with it. There's no commitment. You won't be charged if you go in excess, because by default, we stop you from exceeding the limits. We just cut your service. You can check a box to say, allow it to exceed. Allow it to exceed the base amounts you see here, but then we will charge you if you go into that. This is a bit more detail on what Scott said this morning. So there's a lot of people who said they're MSDN subscribers, and this is exactly what you get for free with those subscriptions. So it's quite a significant amount of free Azure. So it's definitely worth going and looking into, and if you want to start playing with this, it's a good way to get started. The one point to note is the one on the far right there. BizSpark also gets the same as MSDN Ultimate. So BizSpark is a program run by Microsoft that helps support startups getting started. And that's it. So thank you for coming.